Hi, everyone. Thanks for joining us, and I hope you're having a great Inspire. I'm Michael McReynolds from the Azure Confidential Computing team, and I'm joined today by Pierre from Decentric, Sebastian from Enclaive, and Scott from Intel. We're here to talk to you today about confidential computing, Intel SGX, and how the ecosystem is developing. To ensure that we have this as interactive as possible, please submit your questions via the Q&A space, and we'll take as many of those questions as we possibly can between us. Yeah, let's get started. So a little bit of background on the space for those of you who have not heard about confidential computing. Confidential computing is an emerging space that's enabling organizations to enhance security of their applications and data. Today, organizations protect their data using encryption technologies that secure the data while it's at rest and in transit using technologies like BitLocker and TLS. However, there's been a missing part up until this. There's been a missing piece to the puzzle up until this time that our industry has not solved, and that's protecting that data while it's in use. And that's what confidential computing aims to address. We're seeing this space evolve quite quickly. 2 months ago, we released to general availability our second generation of SGX VMs. This enabled major performance improvements generation on generation. And since then, we've been quickly expanding our geographic footprint, launching in various North America regions. We launched across a variety of geographies in Europe, and we've just recently expanded into Asia. Today, we announced the general availability of Azure Confidential Ledger. This is an incredible service that's built using SGX as the backbone. Confidential Ledger enables tamper-proof audit logging, and it enables customers to be able to leverage blockchain technologies to really secure their data and get that tamper-proof service, which is an industry first. To learn more about this service, I recommend checking out aka.ms/confidential ledger. You're going to see more confidential services get built out over the next few months and next few years. And we also have great partner ecosystem that's putting together great solutions. And we have some experts here today to talk you through some of the work that's going on in that space as well. So first, I want to turn to Scott. Scott, could you share a little bit more on Intel SGX and the improvements that Intel are bringing with this generation of Xeon processors?
Sure, absolutely. Thank you, Michael. So Intel Software Guard Extensions, or SGX, as Mike was just saying, is a set of x86 instructions that allows a developer to secure certain parts of his code and data such that nothing else in the platform can get to it, whether it be the host OS or other applications, the VMM in the case of a virtualized environment. Nothing else will be able to get to that code and data that's running on that platform. This is especially important when customers are starting to move from on-prem into the cloud. They worry about their data, of course. That's where SGX comes in. The other big important feature about SGX that we want to talk about is remote attestation. That allows you, running remotely, to attest to your software running in the cloud. To be able to make sure, number one, it hasn't been compromised, changed, modified in any way. And also the fact that that platform that you're running on, even if you don't own it, is up to date, whether it be the microcode, the Intel SGX platform software that we put out, different authenticated code modules running on that platform. You can tell running all the way up in your application, in your enclave, as we call it, the secured memory for your application, that platform is completely up to date, which you want it to be, as a customer wanting to make sure your data is secure. Between that and the base of SGX and the recent release of our third generation Xeon scalable processors, that's really started to have a lot of different and better use cases for SGX in the cloud. The main reason for that is the fact that the available memory for SGX with this third gen Xeon Scalable was increased dramatically from our previous generation, from 128 to 256 megabytes, all the way up to 512 gigabytes per processor, theoretically giving you a max of 1 terabyte in a dual socket system. This has brought about many, many use cases that previously wouldn't be able to be done just because of the limited memory. Things like federated learning or multi-party computation. We have folks like that previously wouldn't be able to necessarily share their data because, for example, different banking institutions or different healthcare institutions now can bring data together, create much bigger data sets, and be assured that no one, even the owner of that platform, can get to that data. And so you could run AI and ML workloads on it and get much better results with that information. And from that data set, the larger data sets, in the case of banking, for example, bringing multiple banks' information together, you can start to look for things like money laundering that you possibly couldn't see just with one bank's information. Just one example of out there. And with ACC bringing in their new DCS v3, really helps and starting to grow the confidential compute environment out there.
That's awesome. Scott, how do you see the security space and SGX evolving here as we get into the second half of 2022 and into 2023?
I kind of just touched on a little bit. There's lots of other new use cases popping up, really, is what I see. Intel is fully committed to SGX for the very foreseeable future. So it will be around for a long time. The customers want to hear that. They like the fact that the very small, SGX TCB that we have with the SGX TE, and I just see that the biggest thing is more and more use cases coming along that weren't possible before.
Okay. Awesome. So Pierre, thank you for being here with us today. Could you introduce our listeners to Decentriq and talk through some of the use cases that you're using confidential computing to help you solve?
Yeah, sure. My pleasure. So yeah, nice to meet you all. Decentriq, we are a SaaS vendor. So we are one of the founding member of the Confidential Computing Consortium, and we offer what we call data clean rooms powered by confidential computing and Intel SGX. So we are a Swiss-based company. The typical problem we solve, and Scott mentioned it already as example of use cases, are multi-party collaboration. So when different organizations need to work together, we basically bring the necessary level of security and privacy for those collaboration to take place. And obviously, confidential computing is at the core of the platform we built. As for the use cases, there are many. Scott mentioned financial services. We at Decentriq are seeing a lot of traction in healthcare space. So typically enabling collaboration between one or multiple healthcare providers with research centers and life sciences companies. And we've been speaking on different webinars with Roche, for example, the work we're doing with them, but also in media. So especially with the deprecation of the third-party cookie, publishers and brands need more and more to resort to using their first-party data, customer data, to build out campaigns. And that's yet again a great use of data clean rooms and confidential computing, because you have the guarantees that none of the respective parties of the collaboration can see each other's data. And we Decentriq cannot either. So yeah, those I would say are the core use cases we've seen. There are many more. Happy to go through more later.
Yeah, so it's great that Decentriq is a pioneer in this space of data clean rooms, really kind of driving the innovation forward in this space. Is there any other industries that are using clean rooms, and kind of specific examples that you could share with us?
Yes, I mean, we are seeing traction in the public sector. So enabling collaboration between public institutions, transportation services, even military and enforcement law, where collaboration is key and data is extremely sensitive. So we've seen a lot of use cases there, and the portfolio keep expanding. I think now we are also working in the supply chain industry, so enabling collaboration between shipping companies and trade finance organizations like reinsurers and banks. So yeah, I'll stop now, but I think just to give you an idea of the spectrum, it's getting very large at this point.
Well, that is a huge spectrum. So thanks for touching on that, and that's awesome to see some of the amazing use cases that are coming out of the data clean room space. Sebastian, so Enclaive, could you introduce Enclaive and just talk through some of the solutions that you're providing?
Yeah, sure. So we at Enclaive, we want to make confidential compute as easy as possible. And Scott already mentioned, in order to enable confidential cloud computing, you need SGX as, say, the base technology. But this is not enough. Typically, you need software, which is SGX ready, which activates effectively the superpower of SGX. And this is exactly where Enclaive comes into the game, because we're developing SGX-ready confidential compute containers, such that engineers, cloud architects, simply can build their confidential compute applications without really worrying about the needy details, which are necessary in order to turn a microservice into an enclave microservice. We offer a large portfolio already of confidential containers, ranging from standard web servers like Nginx or Apache to databases like MariaDB, MongoDB. And this way, we hope that we can just speed up the evolution of confidential clouds.
Awesome. Yeah, we see a lot of innovation in the confidential container space at the moment. A lot of customers, they admittedly want to go multi-cloud, and confidential containers enables that. Could you share any other kind of what sort of customers are coming to you to leverage this? I see that you have a focus on Nginx, and any other specific workloads that you're working to enable?
Exactly. So our portfolio right now focuses on standard web applications. So anything which standard web applications need is something we offer. And Nginx is a running example. WordPress is another one, like a very prominent content management system that empowered e-commerce effectively around 2000, and a lot of other applications in this space.
Okay, wonderful. Just a reminder, if you have any questions, please use the Q&A function, and we'll do our best to answer them. So things that I want to share. So since we've generally available made GA our DCS v3 series virtual machine, again, we're similarly hearing a lot of the same feedback from organizations looking to be able to take advantage of some of the benefits that we've increased gen on gen. With the prior generation DCS v2, we had relatively limited amount of EPC for customers to use, and with DCS v3, we removed those limitations with the partnership of Intel. So we offer gigabytes of EPC memory. We also have significantly increased the amount of compute cores. So that number has went from 8 core virtual machines up to 48 core virtual machines, as well as some of the regular memory increases. We increased regular memory by 12x. So we've been really thrilled with the momentum that we're having with SGX today, and some of the solutions that the marketplace or some of the things that are developing in the marketplace. Scott, I just want to turn it back to you. Kind of any additional things that Intel are working on this year that you'd like to share?
Well, one of the things we've announced, for example, is our Project Amber. I know Microsoft has their own attestation service, but we've had customers who want to run between clouds or hybrid on-prem and things like that. Project Amber is coming out later this year, hopefully, and it will be a different type of CSP agnostic attestation service that you can run anywhere. You can run, like I said, on your prem. You can run an ACC, wherever you need to do attestation amongst different devices. That's one of the big things coming later this year. I think that some folks are really interested in. Right now, that's really one of the big things that we're pushing.
Yeah. No, great. Project Amber is, I was at the Intel Vision conference a few months back when I heard Greg Lavender announce that. He also talked about seamless updates, which is a super important capability for us in the confidential computing space. It'll enable us to securely update, the many servers that we have without reboots for our customers. That's something that we're invested in. We're excited to enable a preview of that in the foreseeable future. Pierre, Sebastian, I'd love to kind of get a sense from you as to some of the conversations that are happening right now, specifically in the European Union when it comes to compliance and regulations. Do you have a lot of customers coming to you both for building greenfield applications, or is SGX really trying to help this kind of cloud? The 80% of customers or so that are kind of stuck on premises and can't move to the public cloud because of security. Love to get your thoughts on that.
All right, let me take that question. So I definitely can confirm customers that are known to have their workload in private data centers, but feel attracted, to move their workloads to a public cloud, are now exploring, in particular, confidential cloud compute technology as the missing component in order to get the trust, the confidence, in order to finally move to a public cloud. And this is definitely the right choice. I mean, in a nutshell, confidential cloud compute is exactly, solving this kind of trust problem, and make sure that a public cloud is effectively transferred into a private data center, right? Still, the compute power is given, but no one really sees what happens to the data, what is processed, what is inside an enclave or inside a confidential container. This is totally intransparent. And me as a cryptographer and a security guy for decades, I love the technology. I mean, I've been really working the last 20 years, in order, to find the holy grail of computing on encrypted data. And finally it is. And moreover, it's practical. And this is sensational. Yeah. So kudos to folks from Azure and Intel, because finally we have a technology which is practical, and that was really open for decades.
Great, thank you. Pierre, any comments that you could share just kind of on regulatory landscape within the European Union and kind of some of the customers that are coming to you to try and help them move to the public cloud?
Yeah, I mean, I guess for us, it's the topic of public cloud is one, but I think Sebastian addressed it, and we got the same feedback from banks who are using cloud for the first time using Azure confidential computing. But I think there's also another angle to this: is how can I still do what I was doing so far, but being compliant with GDPR and other regulation, and that's especially relevant in healthcare and media. So when you look at principles like purpose limitation, data minimization, those are principles that are written black over white in the GDPR law that are just shouting, screaming confidential computing. When you look at confidential computing, you can strictly limit what and attest what that code is going to perform in that enclave. So if you translate that to the GDPR world, it can mean you can be compliant because you can guarantee that this data is used for a certain purpose and nothing else, and that can be attested. Same with data minimization. Data is encrypted and protected at all time. You reduce the surface risk. So yeah, we get very strong feedback from clients who are trying to comply with those new regulations and find confidential computing like a very perfect fit for this.
Perfect. We have one question from Andreas, and I think, Sebastian, this might be a perfect one for you. The question talks about minimizing code changes, for SGX. Sebastian, do you want to share kind of your thoughts? And then Scott, maybe you could share a little bit about Grameen.
Yeah, I mean, there are several approaches how to turn an application into an enclaved application, meaning one that is SGX ready and uses the superpower. And of course, one approach is to simply look into the codes and rewrite those portions of the code which are maybe security critical and should be enclaved. But this is a super tedious job, right? I mean, think about, a complex application has, millions of lines of code. So you really need to go through every line and, in most cases, rewrite a great portion of it. Just in order to give you a number, what we did, I think around 2017, 18 is we went down the rabbit hole and rewrote SQLite, which is just a very, very tiny and simple database, SQL database. But it effectively took us more than half a year in order, to get this product ready. And this is definitely something which doesn't really scale, right? And there is another approach, and this approach comes down from research about libosses, which are something like super tiny operating systems in a nutshell, right? And those operating systems lay a universal interface for any application that runs on top. And now what one can easily do is one just takes the application, and here the nice thing is that it can be a binary application. So you don't have to look into the source code. You don't need to recompile it. You just take the binary, as a standard file, and through the libos, you can simply execute it. And this happens within an enclave. And this is a gigantic step forward, simply because, as mentioned, you don't need to rewrite any line of code anymore. You don't need, to have access to the source code, which is, I think, in a lot of use cases also a requirement, because customers, for example, don't want, to give you access to the source code of our proprietary application. And it definitely reduces the cost and time in order to enclave the application.
Absolutely. That's similar feedback that we hear quite often. Scott, could you share any of the investments that Intel are making, both through kind of open source ecosystem? Obviously, organizations like Enclaive are bringing confidential containers into the mix, but just some of the investments that Intel are making to make confidential computing easier?
Absolutely. We as Sebastian just talked about, LibraryOS is really important to a lot of our customers to bring these pre-existing applications into an SGX enclave. One such offering that is backed by the CCC, the Confidential Compute Consortium, and Intel is called Grameen LibraryOS. And it does exactly what Sebastian said. It takes a pre-existing application, it wraps it in an enclave, provides basically a shielding layer from the untrusted code that it needs to call out, outside the enclave. We are putting quite a bit of resources into making that production ready. It actually is there now. We have customers using it in production right now. And it's been very, very successful. We have a roadmap of new features coming in the future for Grameen. Not only that, we have some internal groups that are actually going a little farther with Grameen and plan to try to provide what we call curated applications, for example, out on the Azure marketplace. And what that would allow you to do, let's say you're a data scientist and you want to secure your data, but you don't want to know about SGX. So you go to the marketplace, you find a TensorFlow that's been, enclavized, put inside a Grameen wrapper, click the button, you're now running an SGX. You didn't have to know anything about it. So those are kinds of the things we're trying to do to make it easier for folks who don't want to know about programming. Grameen works very well for those who do know programming, and it's relatively easy to get going, especially with tools like the one we have called Grameen Shielded Containers, which will take a Docker file, an already containerized application, and do all the work you need it to do to run it inside a Grameenized enclave. Things like that. So yes, we're heavily invested in Grameen, heavily invested in this curated application paradigm, and just hoping to make it easier for folks who don't want to know about the underlying security technology and confidential compute itself. They just want to know my data is secure, my code is secure that's running in there, and any models, AI models and things like that they might want to input. So yeah.
Awesome. Just a reminder, if there's any questions that we don't have many questions that are coming in, but if you have any questions you'd like us to answer, please please share them through the chat. I think one of the interesting things that we're seeing a lot of traction in is we've also taken our Key Vault service and made it confidential with Azure Key Vault with Managed HSM. This is a highly available service which is really helping customers protect their most sensitive keys that they have. We've also taken some of our third-party or our PaaS services like SQL, always encrypted with secure enclaves, and made it confidential using SGX enclaves. So we're excited, to bring that to more markets and to help customers build out incredible applications that can leverage these technologies. Just want to kind of turn it back to the team here on the call. Is there any interesting innovations that you'd like to share that you're working on over the next 6 months? I know that there's a kind of a ton of interest in the space, so keen to understand kind of what's next on your roadmap.
I can shoot first. So I mean, from our side at Decentric, there's maybe two big focus. We are making confidential computing easy for end users, so we are abstracting away all the complexity. That's the key value. But the focus in the next weeks and months will be to make it even easier for certain users to even remove the need to write code. So having a no-code interface, especially relevant in the media space, where we don't want people to write fancy Python or SQL queries even. So making it really dead simple. So that's really one of the main focus of the company, lowering the bar even further. And I think the second piece and the big challenge for us will be combining all the security guarantees that Intel SGX provide in confidential computing with additional guarantees around privacy to guarantee whatever can come out from that enclave. So confidential computing controls very firmly whatever happens inside that enclave, but if we want to be fully bulletproof, we are basically building on top of confidential computing some safeguards, some filters on top to guarantee that there is no way that sensitive patient or customer data can be exfiltrated, even if code is buggy or malicious, having some safe net around it. So those are the two very exciting pieces we're working on.
Awesome. Sebastian?
Yeah. So on our roadmap, we're definitely gonna extend our portfolio of confidential containers just in order to make sure that people can literally, without no efforts, build confidential cloud applications. Yeah, so really making it as usable as possible. And we also recently focused on content management systems. This is somehow the priority right now on our roadmap. We, for example, released a confidential compute version of WordPress, a very prominent content management system. And the reason why we're addressing this, because I believe this is a wonderful use case in order to showcase the power of enclave technology. Because we know, for example, that confidential compute solves the problem of data in use. So finally, we can process data. And in the e-commerce space, where WordPress is frequently used, it's all about, for example, tracking what kind of products people buy. Do they come back to the websites? When do they come back? But these information are very sensitive, right? And they are protected, for example, by privacy laws like GDPR. And this is also one of the reasons why people have always to accept that so-called cookie banner. It's nothing else than just accepting that people allow others to process on this data and extract from the analytics certain insights. But with confidential compute, we can now put the whole analytics into that enclaive, which is like something like a processing black box. And the nice thing is that no one really now sees the private, the sensitive data, but the processing is still happening in that black box. And if this black box, just gives insights, which are by definition GDPR compliant, for example, then we can suddenly create web traffic analytics tools which do not need a cookie banner anymore. And I think this is a great example that really proves the power of confidential compute.
That's awesome. I really appreciate kind of the great work that everyone's doing at the moment. Cookieless is something that is kind of an exciting thing that's going to happen here soon. So Sebastian, on the forefront of that, that's awesome work. Just want to wrap up and just say a big thank you on behalf of kind of the Azure team for joining. Anyone have any final words before we wrap up? If not, just check out some of the call to actions here, some of the links on screen to follow Enclaive, Sebastian, Pierre, Scott, from all of us. Thank you very much, and hope you all have a great rest of Inspire. Pleasure. Bye.
Thank you. Bye-bye.
Thank you all.
Bye-bye.